Okay, so now that we're a little bit more familiar with what a logarithm is and isn't and what it looks like, let's talk about their properties. So first of all, if you don't have one of the fancy newer calculators and using a scientific calculator, this formula, which is called the change of base, is super, super important. Change of base formula. That's because in most calculators, you can only enter base 10 and base e. So if we want to do this, we have to be able to have a way to type it into our calculator. So what I always tell myself is base on the bottom. So I can change number 1 into any base I want. I'm going to put my base on the bottom. So log 25 over log 4. In both of these cases, I've changed the base to 10. Now this is the exact same thing as I could do, I could even do ln of 25 over ln of 4. Here I have made my base e. In fact, you can change it to any base you want. If you wanted to change it to base 2, that'd be log base 2 of 25 over log base 2 of 4. The key thing is that this original base every time goes on the bottom, and the number on the top is always in the same place on the top. And every time the base, top and bottom, was the same. But if you can type any of those in your calculator, you'll get the same thing. With your 4 function, you're probably going to type log 25 over log of 4, or maybe the ln version. For number 2, let's do log 12 over log 2. Or if you want to go to ln, log base e, you do log 12, or ln 12, sorry, over ln of 2. Either one of those will get you the answer. Okay, besides the change of base, there are these 3 key properties that logarithms have: the product property, the quotient property, and the power property. The product property I remember because product is multiplying and it makes things bigger, and the other math function that makes things bigger is adding. So when you are multiplying 2 things together inside of a logarithm, you can add them and break them apart into 2 logs. The quotient property is dividing, which tends to make things smaller. Subtracting normally makes things smaller. So when you are dividing 2 things, you can subtract them into 2 separate logs. Keep in mind that order matters. Whatever was on the bottom has to be the one with the negative sign. And then the power property says if you have a power right here, you can drop it like it's hot and put it in front, which is what happened right here with the n. So let's use these properties to rewrite. So what I have right here is I have ln of 2 and ln of 3. I need to make ln of 6. Using 2 and 3, how do you make 6? Well, 6 equals 2 times 3. So ln of 6 is equal to ln of 2 times 3. Because these 2 things are multiplying, I can break them apart by adding. So this would be the same thing as ln of 2 plus ln of 3. Okay, on the next one, let's rewrite this. These are dividing, so we can subtract. So it becomes ln of 2 minus ln of 27. Now, the ln of 2 is okay because ln of 2 is something I was given. But I do not have an ln 27. I have an ln of 3. So this is ln of 2. How can I use the 2 and the 3 to make 27? Well, I can write 27 as 3 cubed. So ln of 2 minus, remember that power can drop in the front, so 3 ln 3. And there's my answer for that one. Okay, so let's use those properties we talked about from the last page and rewrite things. So let's try this. So on this one, remember I mentioned it in a prior video, but if I have the cubed root of x to the 5th, I can rewrite that as x to the 5/3. It's always the power over the root. So using what I just said, log base 5 of 5, the power on the 5 is 1 and the root is a 3. That's a power, so I can drop it in the front. So I get 1/3 log base 5 of 5. And it says that I want to find the exact value. Well, you can do one of two things here. Let me go back up here first. Right here, do you see how the base and the base are the same? If you remember, these are inverses and they undo each other, so this would leave me with my 1/3, my power up here that was in the top. Now, if you didn't remember that, which is totally okay, there's a 1 power here. 5 is the same thing as 5 to the 1st. This log base and exponential base undo each other, which leaves me with my 1. So this would make 1/3 times 1. And 1/3 times 1 is still 1/3. So either way, you get the exact same answer. Okay, let's try the next one. So the first thing I'm going to do is I'm going to drop those powers down. So I get 6 ln e minus 2 ln e. Okay, well, this and this are the same. So I have 6 of something minus 2 of the same thing. So 6 minus 2 is 4 ln e. Now I'm going to rewrite this one time. 4, instead of writing ln, I'm going to write log base e, because ln is log base e of e. And these two things, just like before, those undo each other and leave you with that 1 power that was up here. So this makes me have a 4 times a 1, or just a 4. Okay, so now we're going to use these to expand what we were given. So that means instead of having 1 logarithm, I'm going to have lots of logarithms. They are all going to have a log base 4. So this whole thing right here is being multiplied, so you're going to add log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Then you just take the 3, it's the only other thing you can do, and drop it in the front. So your final answer is log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. This is completely expanded out. Okay, let's try number 8. So I'm going to rewrite it. They are dividing, so I can subtract. So I get ln square root 3x minus 5 minus ln of 7. I'm going to rewrite that 1, or the square root, as a 1/2 power. You need parentheses because the whole thing was square rooted. And then you can drop that 1/2 in the front. So here is your answer. Okay, now we're going to go in the other direction. We have lots of logarithms, and we are going to squish them down and condense them. Condense them down to one single logarithm. So first things first, pop your powers back up. Log x to the 1/2 plus log x plus 1 to the 3rd. These are adding, so we're going to multiply. So we're going to have log x to the 1/2 parentheses x plus 1 to the 3rd. And there's your final answer. The next one, you pop your power up top. So this is going to be ln of x plus 2 squared minus ln x. They're subtracting, so the one that has the minus sign has to go on the bottom. Oops. Let me erase really quick. Sorry, I didn't leave enough room. So on top, I'm going to have x plus 2 squared over the x. On the next one, I'm going to start with everything on the inside first, and I'm going to condense that down. So I'm going to throw that 1/3 out front. The inside is going to be log base 2 of x times an x plus 1. And please note that every time I do this, I only can do it because the bases are all the same. And then I'm going to take this power, this coefficient, and pop it up top and make it a power. So be very careful you put it in the right place. You're going to have log. The 1/3 has to go to everything. So log base 2 of x times x plus 1. And then the 1/3 goes on everything like that. Okay, the next one. Let's start on the inside. So the 4 and then bracket. On the inside here, I'm going to have ln of z plus 5 minus, I'm going to pop the 2 up, ln of z minus 5 squared. I can take my 4 and pop it up, so I get ln of z times z plus 5 to the 4th minus ln of z minus 5 squared. Those are the same logs, but they're subtracting, so the last step is to condense this down. On top, it's z times z plus 5. That whole thing has to have parentheses because it's to the 4th power over parentheses z minus 5 squared. Okay, this last one. A little bit longer, but we can do this. I'm going to give you a little hint, though. If it's positive, it goes on top of the fraction. If it's negative, it goes on bottom because it was subtracting. So hopefully that helps just a little bit. So let's see if we can do this in a fewer amount of steps this time. So I'm going to have log base, oops, forgot the O in log. Try again. So I'm going to have log base 4. If it's positive, it goes on top, and if it's negative or a minus, it goes on bottom. So on top, I have the 5. Then this 2 would have gone up on my x, making it x squared. This 4 would have gone on top of my y, and it goes on the bottom because it was subtracting. The 2 goes on top of the z, and it was adding, so it goes on top. This 5, it was adding, so it goes on top. These are all multiplied. 5, this x squared is positive, so it goes on top. This is subtracting, so it goes on bottom. And then the z goes on top. And then we just need to clean it up one time. Log base 4 of, on top, I had a 5 and a 5, so that's going to make a 25. I have an x squared and an x squared, so it's going to be x to the 4th. I have a z squared and a z squared, so it's going to make a z to the 4th. And on bottom, it becomes a y to the 8th. Just shorten my bar a little bit. And there is your final answer. Okay, now we're going to do some more expanding. So let's just be very careful with some of these, with the signs. So number 1, log base 9 of x. The y squared and the z squared came from the bottom, so they're both going to be subtracting, minus log base 9 of y squared minus log base 9 of z to the 3rd. The last step is to drop those down, those powers. So log base 9 of x minus 2 log base 9 of y minus 3 log base 9 of z. So there's my final answer. On number 2, we have log base 8. The x and z are both to the 1/3 power because they're both inside of that root. So remember, Laws of exponents means that I can distribute that exponent into both of them. They're multiplying, so I can add. So I can put the power in front, 1/3. Log base 8 of x plus drop the power in front, 1/3 log base 8 of z. This is log base 3. R to the 1/3 over s to the 1/3. Those are dividing, so we subtract. So that gets me log base 3. Drop the 1/3 in front. R minus, drop the 1/3 in front. And there's your final answer. Last one. So this one's going to be ln x to the 5th raised to the 1/2, y to the 3rd raised to the 1/2. They're both inside that square root. So this becomes a 5/2 ln x plus a 3/2 ln y.